So in this question we have a particle on a smooth plane. The plane has a slope of 1 and 7. That would mean that if we were to continue this on here, the sine of this angle will be equal to sine of theta will be equal to 1 over 7. It goes up 1 and 7 across. And what we've got on this is a particle, so we'll just draw in a box for the particle. And this particle has a weight that acts down that way there, mg. So, what we want from this, I'll change the colour here. We want to change this weight into two components. So instead of thinking about it as weight pulling straight down towards the centre of the earth, we want to think of it as weight as a component acting perpendicular to the surface and a component acting parallel to the surface. Now, to complete the vectors for this diagram, I could put another one up here, which would be the reaction. Now, because friction isn't at play, these two are directly equal and there's no frictional, it's a smooth surface. So the only vector that's going to cause acceleration is this one here. The component of weight acting parallel to the surface. So what we have here then is, we know that's our angle theta. We know that our acceleration down the incline is going to be, and I'll just move that mg, it's a bit confusing where it is. I might redraw this triangle completely. This is our angle theta, this is mg, I'm just redrawing that triangle. This vector here is the opposite, that's that right angle there, that's the adjacent. So sine theta is equal to the opposite over mg, or the opposite side is equal to mg sine theta. And we're told that it is a slope of 1 and 7, so that's just sine theta. So the force it'll feel down the incline, I'll call it F, is equal to mg sine theta, or mg times 1 over 7. That's the force. What we're asked to find is the acceleration. So we know the force is equal to mass times acceleration. So in this case it's equal to mass times gravity, it's 1 over 7. We can divide both sides by mass, and we get acceleration is equal to 1 over 7 g meters per second squared. Then we're asked to find out how long will it take to reach a speed of 7 meters per second. And we're into one of our UVAS questions. So we've got initial velocity is 0, final velocity is 7 meters per second. Acceleration is g over 7 meters per second squared, and we're looking for time. So go through the three equations, and the best one to use here is v is equal to u t, v is equal to u plus a half plus at. V is the final velocity. A is g over 9. So v is equal to u plus at. So in this case it's 7 is equal to 0 plus g over 7t, or the time it will take, multiply both by 7, we get 49 over g. 49 over 9.8, if we call it 9.8, is just equal to 0.5 of a second. And I think I'll leave it at that.